figure out how to write the electron configurations based on the periodic table. So if you look at the periodic table, you're gonna notice that it's split in blocks, 4 different blocks, each one belonging to the type of orbital where the valence electrons of these elements are located in. Not all the electrons, just the valence electrons. So these two columns, these two groups, have their valence electrons in s orbitals. That's why this is called s block. And I want you to pay attention. How many electrons can you put in an s orbital? 2, maximum. That's why you have 2 electrons in each little row here, okay? The second block is the p block. How many electrons can you put in a p block, in a p orbital? 6 maximum. That's why every row here in the p block holds 6 elements. 1, 2, 3, 4, 5, 6. Okay? Because every one adds 1 more electron to that p orbital. Okay? The d block is the transition metals right here in the middle. And the d block, the d orbital can hold 10 electrons. There you expect to have 10 elements here. And if you come from left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in every single period in the d block. The s block is the one at the middle, at the bottom. S orbitals can hold 14 electrons, and going from cerium 58 through 71, that's 14 elements, and going from thorium to the last one, it's another 14 elements. Now I want you to pay attention because these two F block elements are going to be inserted in period 6 and period 7 right after lanthanum and right after actinium. Lanthanum and actinium are D block elements. D block. They're not part of the F block. Some periodic tables make the mistake to putting them here as the head of the F block elements. They're not. They're D block. These here, the cerium and the thorium series kind of start after lanthanum and after actinium in this gap. There's a gap, 57 to 72. So here is this part and here is this part. Good, so keep that in mind. So now what I'm gonna do is go and make notations on the periodic table, and that you're going to do with me, okay? And please keep the screen on that. Alright, so first thing first, helium, take it away from here, and put it right here. He belongs from a configuration in the S block. That's your first move. And this first row, first element is 1s. Then the second period starts with a 2s, and these are your lithium and beryllium. And then starting with boron, here you go moving to the 2p orbitals. So lithium and beryllium has valence electrons in the 2s orbitals, and then starting with boron, going through up to neon, you're gonna have electrons in the 2p orbitals. Moving on, 3s for sodium and magnesium, 3p, starting with aluminum, moving to argon. Following? Okay. 4s for potassium and calcium. And here, guys, with the d orbital, remember that the first time you had d orbitals was the 3d. There was no such thing as a 2d or 1d. So the first d is the 3d. Even though d orbital shows in the 4th period, these elements are your 3d elements from here to here. So scandium, titanium, all this up to zinc are your 3d orbitals filling elements. It's like from an energy standpoint, imagine this middle block being pushed up by a spot from an energy standpoint, from an orbital standpoint. Starting with gallium, we're going back to the 4s. 4p right here, it goes up to krypton. 5s for rubidium and strontium. With yttrium, you start your 4d up to cadmium. And with indium, you start your 5p. And here comes the beautiful situation with all the other orbitals. 6s, cesium and barium. Lanthanum is your 5d. Hafnium also is 5d, and all of these up until here are 5d. And here's your 6p. But here in the middle, here in this gap, you're going to put these elements, which are your first F. So these these are your 4F elements that are going to be right here, 4F. So what I'm talking about is that the F orbitals, the first F orbital starts at the 4F. So the first time you encounter F orbitals are here. That's going to be your 4F. So it's like the number of a period minus 2, if you think about it. Okay. So the D orbital is 1 spot away from the number of the period, and the F orbital is 2 spots away from the number of the period. Okay. So 5D is the D orbitals. 5D orbitals are split. 5D, the first 5D is here, and then there are 5Ds here. But in between the 5Ds are basically these 4F orbitals being inserted here, because these elements are in this gap, in this hole. Okay? So here is your, continuing the 5Ds, all these elements, and then we go back to normal. So the S and the P follow the period number. The D is the period minus 1, and the F is the period minus 2, N minus 1 and N minus 2. Okay? The 7 period, 7S, French irradium are your 7S elements. 6D for actinium, and here's the other gap. We're gonna have these elements, which are your 5F. So here in this gap, you put your 5F elements. Once you get out of the gap, you continue with your 6D, all of these elements, and here is your 7P. This is an older version of the periodic table. By now, all these lines have been filled with elements. We have elements all over here, so that's that. But just in terms of orbitals. So, how am I going to write a configuration? I am going to start reading from left to right. If I want to write a configuration of carbon that we saw a little bit earlier, carbon has 6 electrons. 6 electrons have to be put in energy levels and sublevels. So I'm going to start, I need to get here, and I'm going to start reading it from left to right from the beginning. 1s, and I'm counting the elements. 1s, 2, and I'm going to go to the first period, there's nothing else here. So I'm going to write 1s2 as my first energy, that's my first sublevel. So I move like this, 1s, and I count just spots, 2, okay? Nothing else here. Then I'm going to start again, 2s, 1, 2, 2s2. So I'm done with this portion, and I'm moving here. 2p, and carbon is 1, 2. Carbon is the second one. So it's 2p, 2. Okay? If I want to do sulfur, this one here, number 16, I have 16 electrons to place. It's like a seating chart for electrons. Always start, so I'm going to say sulfur that has 16. Okay. To get to sulfur, I start from the beginning. 1s, 2. It's like a pattern. It's the same thing over and over. And then 2s2, and then 2p, and I go through all of them. It's 2p, 1, 2, 3, 4, 5, 6. So 2s2, 2p6, and then 3s2, right? 3s2. And then I take the 3p, and I have 1, 2, 3, 4. 3p4. Because sulfur is the 4th element in the p block. 3p, 1, 2, 3, 4. Good? So, it goes like this. If I give you an element from here, from the bottom, you'll have to write all this over and over again. I know. Lucrative, right? Let's do nickel. Nickel number 28. Let's start from the beginning. 1s, you tell me what to write. 1s, 1s2, and then 2s2, and then 2p6, and then 3s2, and then 3p6, because I'm going through the whole 3p, right? And then 4s2, and then 3d, So nickel is in the D block, so it's 3D, 1, 2, 3, 4, 5, 6, 7, 8. 3D8. Okay? So basically the highest energy sublevel you write, the last thing you write kind of tells you where the element is located. If you look for carbon, let's look for the second element in the 2p zone. 2p is here, second is carbon. Just by writing the last sublevel, you kind of know what element you're talking about. Okay, the highest energy sublevel. 3D8 is this, 3D number 8, nickel. What do we have? 3p4 with sulfur. So you know exactly by looking at what you wrote at the end, you know exactly what element you're talking about. Okay. So I want to point something out to you here for nickel. Oh. How many energy level has nickel? How many energy level? The number of energy levels, all you have to do is look at the beginning of the period, and that tells you how many energy levels it has. Nickel is in period number 4, it's gonna have 4 energy levels, right? 4 circles, basically. So this is the first energy level. 2s and 2p is the second energy level. Okay. 3s, 3p, and 3d is the third energy level. Anything that starts with the same number is the energy level. And then you have the 4s2 being the fourth energy level. Okay. So you have, for these d elements, you actually have electrons filling up the 3d orbitals after they filled out the 4s. So it's a little bit of a awkward situation because basically the 3d orbitals are a little bit higher in energy than the 4s orbitals. Okay, so that's why. So the 3d orbitals, the valence electrons for the d block elements are the d electrons, basically. Okay, now let's write something that it's let's write europium. It's right here in this first gap. So if you want to write, so let me show you a shortcut. The shortcut is called the noble gas configuration. So let's look at nickel. And nickel is right here. The noble gas before nickel is argon, right? Argon is 3p6. So up until here, the configuration is argon, correct? From here I can cut it and I can add to get to nickel. So basically, if I want to write nickel as a noble gas configuration, it's an abbreviation, so we don't have to write the same thing over and over. I can write nickel is, and I put argon in the brackets, the noble gas that is before your element, followed by 4s2, 3d8. So 2 argon, after argon, you go and you add the 4s2 and the 3d8 to make your element. How can you determine your noble gas? Put the finger on your element that you're going to write the configuration for, go one step higher to the previous period, and make a right to go to the end to the noble gas. Okay? So if I want to write the configuration for europium, what period is europium? Where is europium really in? It's right here in this gap, right? So for here, you go one step up and all the way to the right to the end, and xenon is your noble gas. So you write, so if I want to write europium, I'm going to write xenon in the brackets, and then I follow with what comes after xenon. 6s2, then remember that to go in the gap, you have to pass by lanthanum. 5d1, and then 4f, whatever. So 6s2, 5d1, that would be your lanthanum right here, but you have to go through it. And then you get in the hole, which is your 4f, and europium is number what? 6. Number 6, right? In the hole. Go with this? Okay. Okay, we're gonna talk about quantum numbers and valence electrons next.